The name of the game. The science of the very smallest thing is commonly called particle physics. No name is perfect, and this one is confusing in a number of ways. The word particle is potentially misleading. Yes. Physicists study particles of the sand, pollutants, dust, in the space and in the atmosphere, and there are other small clumps of the stuff which have nothing directly to do with the ultimate constituents of the matter. Sometimes particle physics is called elementary particle physics to distinguish it from the study of these composite particles. But this isn't of much help, since protons and neutrons, important tiny particles which are crucial feature in the landscape of the subject, are not elementary. At some point, we may even find out that the fundamental particles of our current theories are not elementary either, although the studying them is definitely a particle physics. Elementary particle physics is also disfavored as a term for a research group or university course because it makes the subject sound too easy. A student who enrolled on an elementary particle physics course might get a shock when confronted with the equations relating to the particles we will be searching for. High-energy physicist is commonly used as alternative, and it is true that the direct approach to the particle physics, basically smashing things together in the huge colliders to see what happens, involves a lot of energy. But some of the key experiments actually rely on hunting for very, very rare, very low-energy particles. Physicists hide their detectors deep underground to try to evade tiny amounts of the noise. And every ultra-low energy jitter is cause for annoyance or excitement. Indirectly, these experiments do tell us something about what's going on at the high energies, but calling them high-energy physics somehow seems a bit inappropriate. Another problem with high-energy physics, as the name is that nuclear physicists, astrophysicists, plasma physicists, and many more all deal with energies that are much higher than those used to probe the limits of the particle physics. The energy of the collision in the Large Hadron Collider, which at the time of the writing is the highest energy particle collider ever built, is tiny compared to the energy that is released in the functioning nuclear reactor, which itself doesn't even register when compared to the exploding star. Whatever the name we give the subject, the investigation is a practical one. The investigation is a practical one, liberated from the realm of the speculative philosophy by experiment, beginning with the human eye, then the microscope, and continuing with powerful particle accelerators and the other precision instruments. Each new generation of the experiments opens up to the human inquiry new landscape of the very small and let us make maps to guide to the way deeper into the heart of the matter. But in the end, the question is the same. Then and today, what is the universe made of, really? When you get right down to it, right?